I'm Lynn Sterry, a researcher at metaLAB and recent alumna from the Harvard Graduate School of Design. My background is in contemporary dance performance and choreography, and current interests include human-computer interaction and communication. I only mention this because in this presentation, I will discuss how I've attempted to create a bridge between my choreographic knowledge and interaction design practice in order to support metaLAB's development of a touchless interactive system for Curatorial A exhibition at the Harvard Art Museums next year. As we head into a post-pandemic world, a challenge we face is how to design a touchless interactive system that will enable visitors to the Lightbox Gallery to interact with our exhibition without having to share or touch any public media. Seeing the touchless requirement as an opportunity, or really as a source of design inspiration, rather than only as a limitation, we are exploring various possibilities, like using movement as input with a camera, so that we can further untether the body from conventional devices like mice and touchpads, thus enabling people to move more freely in the gallery as they experience our work. When thinking about bodies moving through time and space, what better discipline to refer to than dance for our design process? With this in mind, we are using choreographic interfaces as a provocation or a springboard. We have begun by developing a taxonomy and framework for identifying choreographic motifs already in existence in interaction design, as well as choreographic models that can be applicable to the design process of this touchless system. For clarity, in this context, we are defining a choreographic interface as an interface that promotes or increases the somatic and spatial interactivity between humans and machines. We began by observing interactive gestures, which are the movement units that a computer recognizes as discrete input. We classified interactive gestures into these four categories: pedestrian, conventional, customized, and skilled, and oriented them on a scale of gestural acquisition time, which really is about the time it takes for a user to learn the different gestures in these categories. Similarly, we observed interactive choreographies, which are composed of the interactive gestures just mentioned. You can think of interactive choreographies as a system of movement that the computer responds to. The three categories for interactive choreographies are set by designer, imported from world, and composed by user, and these are oriented on a scale of choreographic agency of user, which basically implies the creative freedom or the creative agency that a user experiences depending on the system they're using. This matrix looks at the tension between time spent learning and experience agency. I was really curious to see if perhaps it's worth it for a designer to use interactive gestures that require more time to learn if it would be equated with greater user agency. Not sure if there's enough data to determine any trend lines, but it really was a great thought exercise. Here we examine choreographic models, which are the mental frameworks that a choreographer uses to produce their movement ideas or to compose their dances. These models fall into the categories of movement, space, and time. In the movement category, we have the subgroups cerebral, skeletal, and visceral. In the cerebral, we have models like narrative and conceptual. The narrative, for example, is when a choreographer prescribes certain characters or personae to dancers for theatrical effect. In the skeletal, we have the taxonomic model, which refers to the way that the body can create shapes to produce a movement vocabulary, or to use a movement vocabulary to make a sequence in a dance. Visceral includes the sensorial, which is really about how a choreographer can construct dances in order to use the sense data of the dancers for more textual and qualitative effect. Looking at space, we have internal space, which is the volumetric space underneath the surface of the skin. Parapersonal space, which is the distal reach of the limbs of the dancer from their core. We have interpersonal space, which includes the volumetric and the negative space of more than one body. Architectural space, which is how a dancer's body or dancers' bodies is oriented to the built environment. Looking at time, we have organic, musical, and algorithmic models of time. Algorithmic, for example, is events-driven. A choreographer may ask a dancer to compel an audience member to tell a secret. That may take 30 seconds, or that may take 30 minutes. Now that we had a taxonomy and a framework for discussing dance ideas in interaction design, it was time to get started on some movement research for the touchless interactive system. We began by looking at accessibility, or the idea of inclusive choreography. Working with dancer Judith Smith, who is also in a wheelchair, we workshopped the minimum gestures required for visitors to interact with the digital media projects of curatorial agents. Those interactive gestures included tracking and selecting, zooming in and zooming out. The breadth of disabilities makes designing a universal system near impossible, but there are considerations that can make the system more inclusive, which I learned through working with Judy. For example, we can transform a bimanual gesture system into a unimanual, or even head control gesture system that is free of hand articulation. In the end, we decided to craft a triptych of choreographies that utilize the bimanual, unimanual, and head control gestures just shown. This way we'd have enough material for future user research and technical testing. Coming back to the matrix that you saw earlier, you can see that this triptych of choreographies is definitely set by the designer and utilizes highly customized gesture. That said, the creative agency of the visitor will be restricted, and it will take a little bit more time for visitors to acquire these gestures. This is useful information to have, as we may want to pivot to change these parameters. Here are the choreographic models that we used to create the triptych of choreographies. For time, we use the algorithmic model most, since gestures are performed in an events-driven fashion by the users. For space, we thought it was important to use the architectural model so that we could really move visitors through the Lightbox gallery. For movement, we relied heavily on the taxonomic model when creating the gestures. This is mainly because the PoseNet library that is fueling the machine learning algorithm that we're using really needs clear geometry in order to work properly. We're currently building a machine learning algorithm that can classify the triptych's associated gestures with high fidelity. We've been experimenting in Google's Teachable Machine and have encountered some technical and creative challenges working with the machine vision algorithm. Specifically, the algorithm sees shapes, it sees geometries, it sees bodies still in space, not so much bodies moving through time and space, which is how we define dance. But this is okay, we just need to work with the machine vision algorithm smartly by placing really clear shapes at the beginning and the end of our sequences. Thank you for your engagement with this presentation. We look forward to welcoming you to the Harvard Art Museum's Lightbox Gallery next year, at which time this touchless interactive system will be fully realized and implemented in support of metaLAB's Curatorial Agents series.